if you look at the voltage regulator, the voltage regulator is not actually the part of this diode, but considering its importance, I would like to discuss it here only. The filter voltage regulator, it is actually when you have an RC in your circuit, you will have some ripple in your circuit, in your output voltage. So the DC voltmeter will reach the average or the DC level of the output voltage. The AC RMS meter will read only the RMS value. The ripple will be equals to ripple voltage over the DC voltage into 100. Voltage regulation is actually the no load voltage minus the full load voltage upon the full load voltage into 100. For half wave, we have already talked that VDC 0.318 Vm. For RMS, it is 0.385 Vm, which makes it as 1.21 ripple, 1.21 ripple for half wave rectifier. For full wave rectifier, it's 0.48. Thus, the ripples in full wave rectifier are much less than in comparison to the half wave rectifier. For the capacitor filter, VRMS is IDC by 4 root 3 FC and VDC is VM minus 4.17 IDC by C. Now VDC by VR by VDC will be approximately equals to that. The small c is equals to comma large time is small current, small c large time small current, and large c small time large current. Okay, this is the condition that is being followed. IDC is T1 over T into IP. Since the average current drawn from the supply must equal to the average diode current during the charging period, the following relation follows, where T1 is the diode conduction period, T is equals to 1 over F. For a full wave, IDC is the average current drawn from the filter and the peak to the conducting diode. This is again the RC filter, not discrete voltage regulation. There are two types, one is series and the other is parallel. In series, we have the control element, we have a comparator, it could be an amplifier or a limiter, anything. We have a controller element, mostly it is a BJT. BJT is a controller element, and then sampling. Sampling circuit could be a voltage divider. Mostly it's a voltage divider in our case. In parallel, we have the control elements in parallel to the comparator and the feedback, and there is an external road also across the wheel. So if you see a series voltage, as we have talked about, this is the controlling element. This is also a comparator right now. This is a comparator right now. Plus minus Vz, which compares. This is a sampling. So Vz plus VBE, Vz plus VBE is equals to Vz plus VBE2 is equal to V0 R2 upon R1 plus R2. For this, we have our controlling element, our comparator, our sampling, our reference. So we have all the four parameters, and our output V0 is 1 plus R1 by R2 into Vz. We have used. Now this is 2014 question, and you can see that it's a Vz, reference, comparator, control element, and a potential divider. Okay, and the output you get with the help of Vz into Vz is equals to R upon R plus 1 into 9, and you get the value of R from there. Shunt regulator is where the control element is in parallel, then reference, what is the comparator in this, sampling, reference, comparator, control element, then VL is equals to, there won't be any potential sampler in this case, I think so. Then Vz is equals to, and shunt regulator VL is equals to Vz plus VBE, and in shunt you have the control element in parallel. Remember that control element. This is VZ, VBE, VBE2, VBE1, VE2, VZ, and VL. There won't be any sampler as such as voltage divider, but yes, all the voltage across the load resistance will be equals to the summation of the various elements or the components present in the circuit. So with this we have come to the end of our topic. Thank you so much for being so patient and long to be with me. I would like to suggest you that GATE is not a very easy examination. It is a tough examination which tests various aspects of you. One of them is to try to solve different type of questions, but because the practice makes you important as an engineer, we cannot afford to make any calculation errors. So with this note, thank you everyone. I hope you like this video. If you like this video, kindly press the like button. Share it with other people, with other friends who are preparing for GATE, and subscribe to my channel for more videos. Thank you. Bye.